Hi, today we are going to see the implementation of Boolean expression using NOR gate in lecture 13, and this is vanilla. So this is the syllabus that we are seeing in the series here, and then we are in the last topic, that is implementation of Boolean expressions using your NOR gate, universal gate. So already we completed the NAND gate in the previous lecture. So here we are going to see the NOR gate. So universal gates, they have two universal gates, NAND and NOR. So NOR is said to be a universal gate because any basic logic gate can be implemented using this one single NOR gate, right? So implementing NOR gate using your NOR gate. So NOR gate is a single input gate. So X, if you give input, output will be your X bar. So actually, what's your NOR gate here? So NOR gate is nothing but if you have input as X and Y, your output will be for R, it's going to be X plus Y, and then this bubble you have your whole bar. So X plus Y whole bar is your NOR gate. So if I just combine these two inputs as X, because NOT is a single input. So X now X plus X whole bar. So which is nothing but your X bar. So I'll be able to get NOR gate using your NOR gate. Then implementing AND using NOR. AND gate, if I give input as X and Y, your output is X into Y. So here this is going to be an OR gate, input X and Y. So what happens? X plus Y whole bar, but I should get X into Y here. So X plus Y whole bar, what is the De Morgan's theorem? A plus B whole bar equal to A bar into B bar. So X bar into Y bar, but I need X into Y. So if I give input as X and Y, I am getting X bar into Y bar. If I give the implementation invert the inputs, then I will be able to get your X. So X and Y, so I will be getting X bar and Y bar. So output will be X bar plus Y bar whole bar. So which is nothing but A plus B whole bar formula, De Morgan's theorem is nothing but A plus B whole bar is nothing but A bar into B bar. So here A bar, what's your A? This is going to be your X bar whole bar into Y bar whole bar. So which is nothing but X bar whole bar is X and Y bar whole bar is Y. So I'll be able to get AND gate using your NOR gate. Implementing OR gate using the NOR gate. So OR gate is X and Y input, now output will be X plus Y. So in your NOR gate, if I give input as X plus Y, output will be X plus Y whole bar. But I should get only X plus Y. So what I should do, I can connect NOR gate in the output. So I will be able to get X plus Y. So this is how I will be able to obtain OR gate using your NOR gate. So using NOR gate, I will be able to get NOT, AND as well as OR. That's why we are saying it is a universal gate. So procedure for the NOR implementation is draw the logic diagram for the Boolean expression using the basic logic gates. Then you have to convert all OR gate to OR invert. Why is it so? So here OR gate I have. So if I have OR gate, if I add bubble in the output, so what happens? It will be converted into a NOR gate. So that's why OR gate to OR invert. So whenever I just introduce a bubble, I should compensate it at the other end of the line here. That you should always remember, so that the value of the expression will not be changed. And convert AND gate to invert AND. So why is it so? Here I have your AND. So if I have your input as X and Y, so invert AND, what happens here is, if I have the bubble here, right? So if I have this bubble, what happens here? X bar, so bubble here. So X bar, Y bar, so it becomes X bar, Y bar. So X bar, A bar, B bar is nothing but your A plus B whole bar. So which is nothing but your NOR gate. So OR invert and both the NOR gate. So check all the bubbles. So while I am introducing the bubbles here, I should compensate the bubbles on the other end, so that the value of your expression will not be changed. Finally, convert all the OR invert AND to NOR gate. Again, NOT gate to single input NOR gate. So we'll solve the problem here. Realize the function f is equal to a plus b into c plus d using NOR gates, right? So a plus b OR gate I will be using, and then similarly c plus d I will be using another OR gate, and then to combine these two things I will be using the AND gate. So here this I will be able to get a plus b, and here I will be getting c plus d. So multiplying will get your f. Now the first thing is over. So I have implemented the logic diagram using basic gates. Second step, convert the for NOR you have to convert OR into NOR. How to convert OR into NOR? If I introduce a bubble in the output of your OR gate, it will be converted into a NOR. So I should compensate here other end. So this bubble will get a normal value. So I should compensate here. Right? Similarly, here I have one more OR gate, so I have to compensate here. So only two OR gate is there, so I converted two OR gate into a NOR gate here, right? And then the third thing is I have to convert your AND gate into NOR. So AND gate to NOR is nothing but invert AND will be your NOR gate. So here only one AND gate is there, and the both inputs are inversed already. So automatically I can convert into a OR gate. So now this entire logic diagram has only the NOR gate. So this is how you have to implement your Boolean function using your NOR gate. First you have to draw the logic diagram using your basic gates, convert all your OR to NOR by introducing your bubble and the output, and convert your AND to NOR by making the bubble invert and then convert your NOR gate. So we'll solve one more problem. So simplify f of x comma y comma z is equal to summation of minterms using k-map and implement using your NOR gate. So first using a k-map I will have to implement the function here, right? So this is going to be the k, and then first we will mention the cell value here. So what is it? It's going to be 0, 1, and this is going to be 3, 2, and this is going to be 4, 5, 7, 6, and then you know it very well, right? So place the minterms, right? 1, 2, 3, 4, 5 and 7. So now we will go for the grouping. So first always we have to aim high. So we will see octet is possible, it's not. Octet 8, it's not possible. So I can go for quad here. 4 adjacent cells. So 1, 3, 5, 7. So this is going to be the group. Another one is I can go for pair. So this is going to be a pair here. So 3 and 2 is an adjacent cell, and 4 and 3 is 5 is an adjacent cell. So I have grouped all the minterms here. So how to write the expression? So this is quad here. X bar x will get cancels, y bar y will get cancels, only z is pending. So I have written z. The next I will go for this pair. So this pair x is there, and then z bar z get cancelled, so y bar is there, so x into y bar. Then here for this pair I have your x bar, and then the z and z bar will get cancelled, so I have y, so x bar y. So I have 3 terms, so 3 groupings, 3 terms here. So here I have to implement using NOR gate. The first part is over, second part I have to implement using your NOR gate. The first thing is I have to draw the logic diagram using your basic gate. So here I will get your x bar y, sorry x y bar, right? So x y bar, and then next I will have your x bar y, then z. So all these things to be clubbed together using your OR gate. So this is what I have got, right? So this is going to be your x y bar, and this is going to be your x bar y. This is your z. If I add up all these 3 things, I will get your f. So in your NOR implementation, the next step is I have to convert OR gate into a NOR gate. Here I have only one OR gate, so I will be converting this one by introducing the bubble, so that I have to go for a NOT gate at the end, right? So this is the compensation, so that my value will not be changed. So second thing is I have to convert your AND gate into a NOR gate. So here I have 2 AND gates, so invert AND will give you the NOR gate. So here one end I have your bubble, so other end I have to introduce a bubble here, and then I have to give the compensation of NOT gate. And here in this one ring I have a bubble, so here I have to give the bubble and then I have to give the compensation too. So now what happens here? This has been converted. So here this bubble, this and is converted into NOT. So only I have your NOT gate. Similarly here in this one, this bubble will convert it into a NOT, and then I have a NOT gate. Now what happens? I have converted OR into NOT and into NOT. The last one is to convert your NOT gate into a NOR gate. So single input NOR gate will give you the NOR gate. So now I have implemented all the things in the NOR gate in the logic diagram. So this is the problem for practice here. So if you have any problem or doubt, you can post it in the comment box also. Thank you guys. Have a nice day. Subscribe my channel for automatic.